Okay, hello fourth grade. I am going to go through and do the day one lessons in this video. I'll get as far as I can here. If you weren't able to attend our meets, our Google Meets, then you can use this to help out. So in this part, it is all about this thing called equivalent fractions up here. Equivalent fractions. In other words, fractions that are equal. That's what it means. Fractions that equal each other. And what that means is, so like for example, if you have two pizzas, okay, and these will be small pizzas, and we take half over here, and I eat half of that pizza, and then I cut this pizza in half, and then I cut it in each part of that in half, and I eat two slices of this one. So what's happened is I ate one big slice here, and that was half of the pizza. Then I ate one big slice here, or I'm sorry, then I ate two little slices here, and that was also half the pizza. So that's 1/2, and this is 2/4. But what we see is they're equivalent. In other words, 1/2 equals 2/4. And that's what we're going to be going through in this video. What are equivalent fractions? So I'm going to erase some of this so I can use in our room here. Okay, and then the big skill also is to do it on a number line. So they're going to be asking you to do it on a number line here. So we'll stay with blue, purple kind of. So this one says find a fraction equivalent to 4/6. And I have a little arrow here that says this means there's 6 parts. 6 parts to make a whole. So keep that in mind. Okay, so we're going to find a fraction that's equivalent. And on the number line, here is where 6/4 is right here. So one way to think about this is to think about putting a Twizzler on the number line. So I'm going to pause it and I'll make a little switch to a different file here. Okay, so I came back to this and I am going to do 4/6. Okay, we're going to do 4/6 and put this on the number line. But what I want you to think about is, what if I put, like, a Twizzler is like a long candy. Usually they're like this color here, this kind of red. So if instead of a pizza, if I pretend I stretched a Twizzler out right across this number line right here, then I took that Twizzler and I broke it into 6 parts. So I'll cut it in half first. Then I'll cut each one of these halves into 2 more pieces. So now what I've got here is, I've got this, for example, is one little piece, and I have one of those pieces, 2, 3, 4, 5, and 6. So looking just at the number line part, and here, this would be one piece. This is the end of the first piece, okay, the end of the first piece. One piece and 6 to make a whole. This would be 2/6, 3/6, 4/6, 5/6, and one whole is the same as 6/6. So now, if I want to find, so basically when they say find a fraction, they mean, well, cut up your pizza, or in this case your Twizzler, into different size pieces, and we'll find an equivalent one. So I'll make a green Twizzler down here. Green piece of candy, and let's cut this one up. This time I'm going to cut this one up into 3 parts. This is how they were showing you before. So put one here, one there. So now this is a bigger piece, and it takes 3 of these. These are bigger pieces, so it takes 3 of them to make one whole Twizzler. This would be, of course, the end of the first piece. That's one piece out of with 3 to make a whole. 2, this represents 2 full pieces, and there's still 3 to make a whole. And this is 3 out of 3. Let me fix this. You can't really read this. It's supposed to say, I'll put this up top here. It doesn't matter. This is 6/6. That on the top, that means I've got 6 pieces. So you can say, well, what's equivalent? Well, if you look here, and I'll use this gray line to kind of dot this, I draw this little line down through here, So you can see that 4, 6 right here ends in the same amount of Twizzler. They're smaller pieces, but 4 of the 6 pieces is the same as 2 of the 3 pieces. So 4, 6 is equivalent to 2/3. And that's what this lesson is about over here. That's what they've got down here. And you can see on the number line, so what you want to learn from this is where those two fractions can be written on the number line. For example, here you have 1/3 is equivalent to 2/6. And here, this is where 2/3, it shows, is equivalent to 4/6. So it might help to think of a Twizzler, okay? All right, let's go on down here, the next one. So it says, look at the number line, write the fraction equivalent to 2/3, or 2/6, when we just did, that's 1/3. Number 2 is the same thing, fill in the missing fractions on the number line. So here you've got here's the 0, and this is where you have the whole. This would be like from here to here is the whole Twizzler, right? And here you've got one piece, that's 1/8. Another little piece here would be 2/8. Because we want you to make sure you understand, you're talking about the actual space when we talk about these. There's 3/8, 4/8, 5/8, 6/8. Okay? And if we kept on going, 7/8 and 8/8. Now, the other part they're showing on the number line are fourths. So, for example, this piece, you could do this in green. So this bigger piece is 1/4. And notice that 1/4 is the same as 2 of the smaller pieces, or 2/8. And that's where they're getting this from down here. Okay. We go up to the next one. This would be out here, would be 2/4. Okay, because let's do the next big piece, right? And 2/4 is the same as 4/8. So 2 big pieces the same as 4 little pieces. 2/4 same as 4/8. And 3/4, let's go out here and do one more of those big pieces, is the same as 1, 2, 3, 4, 5, 6/8. Or you can look around the number line and see right there it says 6/8. Okay? Alright, and again, you can stop this video and go back and look at some of these things, okay, to help yourself out there. Alright, so this one says, look at the models, shade the models to show 2 fractions equivalent to 3/4. So here, this first one is, I don't know if you can see that all the way, but basically there's your Twizzler or your pizza, and there's 1, 2, 3, and you can see you've got 1 piece, 2 piece, 3 pieces, 4 pieces right here. Okay, so that's 3, and there's 4 to make a whole. Down below here, what you've got is, this time you've got your pizza or your Twizzler, and it is broken up into 1, 2, 3, 4, 5, 6, 7, and there's 8 pieces. If you count those sections, that's 8 pieces. So we know the denominator is going to be 8. And what's equivalent? Well, let's look. We have to match up with this 3/4. So starting from here, and you can kind of see what's happening. For each big piece up here, there are 2 little pieces. So that's where they get 3/4 is the same as 1, 2, 3, 4, 5, 6/8. Okay, let's look at the next one. The next one is broken up into even smaller pieces. Now this is interesting. So 1/4 right here is equal to 2 of these 8s, right? And that is equal to 3 of these things. So I wonder what that is. This is 3 times the number of pieces. Okay, that's 1/4. There's 2/4, another 3, right? Another 3 little pieces. And 3/4, 3 more of those. So we can count by kind of groups of 3 here. 3, 6, 9. So there's 12 total to make a whole. And we would shade in 3, 4, 5, 6, 7, 8, 9 of them. So these are equivalent. In other words, 3/4 is equivalent to 6/8, and 3/4 is equivalent to 9/12. There you go. Okay, let's take a look at the next one here. Use the models below to complete the sentences. The models show wholes and parts. Those are those big ideas we've been talking about, wholes and parts. There's 3 wholes. Each is divided into fourths. So here are the wholes. There's 1 whole pizza, 2 whole pizzas, and 3. So just think of it as pizza, 3 whole pizzas. Each part is what of a whole? So one of these parts like this, each part is, that would be 1 out of 4 parts to make a whole. So each part is 1/4 of a whole, okay? Now how many fourths are there in all? Well, there's a lot of them. There are 4 in this pizza, right? 4 in this pizza. 4 in this pizza. Which makes sense. There's 4/4 in each whole. So that's 4, 8, and 12. That's 12 fourths in all, which looks like this. 12, hold on a second. So 12 fourths. Now look at this. This is going to look kind of strange here. It can be written as like this. 12 fourths. And you might say, wow, it's kind of weird to say 12 fourths. Well, normally we don't leave it in that form, but you can do that. You can do that. But normally it's called an improper fraction. Normally you would change it back to say, well, how many wholes? You wouldn't come home from a party and say, I had 12 fourths. You'd say, well, you would know that 12 fourths, you could sort of decompose it. So 4/4, that's 1 whole. There's another whole. And there's another whole. So that's how you can see that 12 fourths is equal to 3 whole pizzas. All right, let's look at this next one here. It says, look at the models below and write the fractions they represent. Are they equivalent? Okay, so this one, there's my whole. It's divided into 2 parts. And I have 1 part shaded. So that's 1/2. So is that the same as this? 1 whole. And it's divided into 4 parts. And I have 2 parts shaded. So 4 parts to make a whole and 2 shaded. So is 1/2 equivalent to 2/4? Okay. So you could think of that in several ways. One thing you could do is you could sort of think about redrawing this, and you could say, well, what if I let me just erase this here. Do it in a different color. You could sort of imagine, you take this whole here, and then let's cut it just like we did the other one. So this one over here is cut right across the middle. So imagine, what if you took this part, this triangle part right here, and you moved it over to here and shaded this in. And then imagine if you took this and moved it right to there. So that's what I'm doing. I'm moving these over. So if you did that, you would end up with something that looks like this. If you move those 2 triangles, and if you could like cut them out and place them over there, and then that would prove that 2/4 is the same or equivalent. So another way to prove that is just to draw a different pizza. So I'll show you. Probably an easier way to think of it is just to draw a pizza like this. Draw 2 of them, one right on top of the other. Okay, cut this one in half down the middle like this. There's 1/2. We'll cut this one again, but then we'll also cut it into each half into 2 parts. And so we have 4 parts to make a whole, and we'll shade in 2 of those. So let's do that. And now you can see that this is 1 big piece, and that's the same as if you ate 2 little pieces, you would eat the same total amount of pizza. You would eat more pieces here, but in total you would be eating half of that whole pizza. How would you explain that? You could either look at your drawings. So when you write an explanation in math, you can very often say, it says, are the fractions equivalent? So you have to answer that, and then you would have to explain. So you could start by just saying 1/2 is equivalent to 2/4. And then you could say, I proved this by drawing, this is just one way to say it, by drawing the two models, or pizzas, you could call them either one, but in math they usually use models, the two models above. And then what you can do on a math explanation, you can just draw an arrow. As long as you draw an arrow to what you drew, then your explanation will be clear and people will understand. And that's perfectly acceptable. Okay, so now you're done with that. And now it's just time to do the fluency. So we're doing 42 times 38. Let me pause and set up an arrow. Okay, so you can do this part of your fluency, 42 times 38. You can use this. Eventually, you're going to want to learn this just to do the standard algorithm. But you can also use this area model over here, and that's perfectly acceptable. And there are other ways to do this as well, but these are the two that we've kind of talked about. So let's do the area model, and then we'll compare that to the standard algorithm and see how that matches up. So here we have 8, so I'm over here looking at the 8 and the 2. 8 times 2, 16. Then I have 8 times 40. So I have 8 times 40. I'll write that down here. And I've got a math fact. 8 times 4 is 32. And that 0 tells me that I'm actually multiplying it times 10. Because if I decompose 40, it's 4 times 10. So 32 times 10 means just one shift on the place value chart. So if everything shifts over, there would be a 0 there. Okay, and I can quickly review that. Hold on. Okay, I just drew a place value chart down here, and just to remind you that 32, whenever we multiply something times 10, it's just shifting these digits to the next place value over, because that's how our number system works. If we have 10 in one spot, like 10 tens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, you got to bundle those, last year, and then you move those over, because 10 tens is worth 100. So 10 times that amount. So what that means for our number system is, it's just a super easy way to do it. So times 10 means I just get to make it one more place value bigger. So that 3 goes to the hundreds place, that 2 goes here. So I have how many ones now in the number? I have 0. That's why I've got that 320. Okay, whoops. Let's go back to our problem here. All right, so we said this is 320. So let's go ahead now and let's add those two partial products. So if you add 320 and if you add 16, I'll just do that down here. I'm adding those two partial products, 6, 3, and 3. So that's 336. So where does that show up on the standard algorithm? Let's watch. Let's go here. We'll multiply times 8 just like we did over on the area model. 8 times 2 is 16, except for this time we put down 6, and 16 means 6 ones, and 1 10, so we get to put that in the 10 spot. 8 times 4 is 32, plus 1, 33. Also, when you're doing this, if you know you're going to multiply by 8, you can write these facts on your paper. 8 times 1, 8 times 2, 8 times 3, and that's what I recommend you do. Save you a lot of time. Okay? You only need to go up to 8 times 4, as you can see here. So that's how that works. It matches. Okay, now we'll do 30 times 2. So I won't go through that again. That's 3 times 2 math fact of 6 times 10, 60. Okay. 30 times 40. I'll take a quick look at that one though. Let me give you some space down here. 30 times 40. Okay. Have a math fact of 3 times 4. That's 12. Each one of these numbers can be broken down into 3 times 10, and that's 4 times 10. But what's really important is, that means we're going to multiply times 10 and times 10 again. Or you could look at the string of numbers I wrote down here, and you could do 3 times 4 is 12, and then 10 times 10 is 100. So let's go to our place value chart. So I've got, oops, let me get a pen here. I've got 30 times 40. I've got 3 times 4, which is 12. And then these two zeros tell me that I have 10 in this number. 10 times 10 is 0. So really what I have is 12 times 100. Right? 12 times 100. Which is the same as, and 100 is 10 times 10. So really I'm saying times 10. And I get to do another shift times 10 again. You don't have to write the times 10. I'm just showing you. You're just shifting over 2 place values. So that 1 goes from the tens place value times 10 to the hundreds place value and to the thousands. This one also has 2 shifts. So now my new digit, or my new number, sorry, has 1,000, 2 hundreds, 0 tens, 0 ones. It's 1,200. We'll go back and put that in our area model. 1,200. So if I had 1,200 plus 60, gives me 1,260 for that partial product. So let's come over to our standard algorithm and do the same thing. Now I'm going to cross this 1 out up here because I'm not going to use that again. That was just for when I was multiplying by 8. Alright, so now I'm multiplying by the 3, and the 3 is in the tens place. So I'm going to put a 0 here in the ones place because I'm not going to be multiplying by anything in the ones place. So basically, technically what I have here is 3 tens times 2 ones. There's that 60, remember that? So this time I'm going to put 0, carry 6. But there is the 60 over here. That's where it was in our area model. And now I have 3 times 4, but technically this is 3 tens times 4 tens. That's what we did over here. We had 30 times 40. So 3 times 4 is 12. And then I get to add plus 6. Hold on a second. Okay. Sorry guys, I made a mistake here. I'm trying to do this too late. I'm going to back up, so you in the recording, I'm going to back up all the way and go through this again. I wanted to try and connect these thoughts together. So again, we're going to back up. I'm going to multiply by the 3, and that's in the tens place. So I'm going to put a 0 here because I'm not in the ones place. So I have 3 times 2. That is 6. There's our 60. There's the 60 that I tried to point out. And earlier I carried it up here because I was trying to point out that it was 60. But hopefully that's clear. 3 times 2, that is 60. 3 tens times 2. Now I'm doing 3 tens times 4 tens, and that's what we did over here. But with the standard algorithm, I don't have to think about all that. All I got to do is look and say, oh, 3 times 4 is 12. And it automatically, look, comes up with that partial product. So now let's just add the partial products. 6, 9, 5, and 1. That's our final answer. I can do the same thing over here with the area model. 6 and 0 is 6. 3 and 6 is 9. 3 and 2 is 5, and 1. So those are the 2 ways that you can do that. I think at this time I will just go ahead and quickly I'll do the answers, and then that way you'll have those. Okay, so let me pause it and I'll just write the answers. So make sure you attempt yours first, and then you can go back and look at the answers, and you can email me if you have trouble getting these. Okay, so I just went ahead and worked these through. So you're going to want to try those, and then if you have any questions, come see me. Just wanted to point something out. Look at these 2 right here. Look at these 2, and think a little bit about why would these 2 products. So the product is the answer in a multiplication problem. Why would the products be the same? Okay, this one is 37 times 48. That's 48 times 37. So look at that. Look at that. All they've done is switch the order. All they've done over here is switch the order of those 2 factors. And that is the commutative property. Means you can change the order in multiplication. So technically you could have looked at this one and said, hey, I don't even have to do it. It's got the work. It's already done right there. I didn't even notice that till I was done. Okay, I hope this is helpful. Give me an email if you're having difficulty. Good job. Hang in there. We'll see you next time.